Thanks again for joining me today, Bill. I'm speaking with Dr. William Moomaw, better known as Bill, Dr. Bill Moomaw, who's a climate scientist who's been working for 32 years on the most effective interventions for humanity to try to reduce its carbon footprint. He's also been the lead author on 5 different IPCC reports. And for those who are not familiar with that abbreviation, it's the Intergovernmental Panel on Climate Change, which was chartered by the United Nations Framework Convention on Climate Change. These are volunteer scientists who have no skin in the game other than trying to get the most recent science out that they are allowed by the rules to get out. And I mention that because unfortunately the rules keep the most recent science out. And I regard that as the parties to the negotiations not wanting to be told the urgent truth, but that's my studied opinion, shall we say. Bill is also emeritus professor from the Fletcher School at Tufts University, and he's a visiting scientist at the Woodwell Climate Research Institute, which went through a name change recently from the Woods Hole Research Center. In order to insert the word climate, they became the Woodwell Climate Research Center. And Dr. Woodwell was actually the first to go before the American Congress 2 years before Dr. James Hansen more famously perhaps said, climate change is here, it can be detected. Okay. So there you have it. Now, I wanted to start off our conversation today with a somewhat provocative question or assertion. I'll ask it as a question, but many of the people who watch the videos that I publish assert that we've gone too far, that it's too late, that we can't do anything about it. It's downhill now, guys. Enjoy your life. Kiss your kids goodbye. Or I'm being a little bit melodramatic. So my question for you, in your opinion, in your heartfelt feeling, is it too late? It's an emergency. What do we do in an emergency? Just speak to that question.
Well, first of all, I would agree that it is an emergency. I use the word emergency deliberately rather than crisis or any of the other terms that are often disaster or whatever, because those imply that that it's over and there's nothing we can do about it. The disaster has happened. We could be in that situation where we end up with an out of control system that, as it warms, it causes changes in the environment that cause more warming. And we're beginning to see some signs of that. But my understanding of this, and I'm not an expert on all aspects of that, but I do work with the scientists who are, is that we are not beyond the point of no return. It is not as though the point of no return would be, I've jumped off the cliff and there's no going back. I'm going to hit bottom. You know, I'm fine until I hit bottom. Yeah. And at that point, it's over. Yeah. We're not in that state.
Now, mind you, the it's over is not the next day, not even the next year. The it's over is a downhill slide of we're not sure what.
We're not sure, but it'll be it. I mean, we have time, and we know what needs to be done. What we seem to lack is the capacity and the will to work together, both at all scales, from the individual scale, our community scale, our state scale, our national scale, our international scale.
Personal scale.
Yes, we start with personal scale, and I can say a few things about that. There are things that we can do ourselves. There's things that we can only do as a society, and things we can only do internationally. And so we need to look at each of those. And I'd like to just kind of run through some of those.
I'll welcome that in a moment. I just want to make the note that the things that have to be done at a national scale there are few, if any, governments, in my opinion, that are prepared to do what needs to be done at a national scale, because it would mean changes that would cut back on GDP. And GDP seems to be the golden calf to which governments make obeisance and daily sacrifice. They sacrifice, they throw people under the bus for the sake of GDP. But I want to point out that if our governments are not ready and willing to do those, then it's up to us to push them. And I'm not talking necessarily about push them in an orderly manner like petitions, which is a good way to go. But I'm talking about sometimes extreme manner like civil disobedience. I am a proponent of civil disobedience for many years.
Well, you know, it's ironic that people say that it will interfere with the GDP. If you look right now, the increase in the stock value of the solar companies, the electric automobile companies and so forth, and compare that to the decline by about half of the oil and gas stock evaluations, suggests that maybe one of those is a sunset industry and the others are sunrise industries. And it is true that we are somewhat constrained by the options that we have that are provided by the industrial system. I often wonder what would have happened had the horse and buggy industry been able to keep Henry Ford from introducing his vehicle. You know, we'd still have buggy whip makers, but we might not have any buggies or you know, to use them with. And unfortunately, the automobile companies, the oil and gas companies, the coal companies, the electric power utilities have all been basically defending literally 19th century fuels and 20th century technologies, and have gotten government to actually make it harder for 21st century sunrise technologies and products to arise.
I have another background which I think will be more apt for this part of the discussion. And let me explain it to our audience. This diagram was given to me by a fellow who we both know. His name's Mark McCaffrey. He's a curriculum expert, American, who specializes in education, climate education. And he and colleagues came up with this diagram, and let me move to one side. And it basically is a powers of 10 diagram, where P0 is 10 to the 0 power, which is 1. So a P0 solution is something that one person can do, such as eat less meat, such as walk to the grocery if it's a couple blocks away instead of driving. Okay, that's a P0 solution. A P1 solution is 10 to the first power, which is 10. A P1 solution would be do it with your family. Okay, do it with your neighbors who live in the immediate. A P2 solution is 100 people, 10 times 10. Well, that's your garden club, so to speak. Okay, so as you discuss the interventions, many people call them solutions, I call them interventions. I think the word solutions gives the wrong impression, like we can put things back the way they were. But whether you call them solutions or interventions, I want to leave this diagram up while you talk about what you have to tell us we should be doing.
Okay, and what I'll do is I'll spiral around it from the
good.
From the single to the multiple levels.
Spiral out.
Spiral out, yes. I'm speaking to you today from a home that my wife and I moved into 13 years ago, more than 13 years ago, in 2007. We began designing it 15 and a half years ago. And it was the first engineered zero net energy home in New England at a time when, quite frankly, there wasn't as much global warming. It was even colder. And so we had to meet the condition of heating this house, operating all of the electrical appliances and things that we feel we need in the 21st century, run a well pump, and operate everything we have. So it's an all electric building, and we succeeded. In fact, it is now not a net zero house, it's a net positive house. We export more to the grid than we import. We're connected to the grid because if we did it all with batteries here, there'd be days when we were just wasting electricity. You know, we're making more than we can use. Our batteries are full, and then it's wasted.
Bills.
And so instead we export it back to the grid, and somebody else gets to use those solar electrodes. In fact, we're doing so many that every couple of months we send about $500 worth of electricity to my son's apartment in the same town. And so we're actually
Can he actually choose that electricity?
Well, we've chosen it for him, and he doesn't seem to complain because he doesn't have to pay those bills. So it's a good outcome for everybody.
How do you spill it right to his house?
Well, you don't, of course. I mean, basically what happens is that it goes into the grid. Those electrons go wherever they go. But it's a question of who gets credit for them.
Oh.
And so we know that how much we're supplying to his house. So we're doing our house and about half of his apartment.
And there are certain states that actually permit that kind of thing where a consumer can say, I choose solar electric, even if it's going to cost me a little bit more.
That's right. In fact, we do that for what we import at night. And so we pay that extra at night. So I think we can say we're really about as close to zero carbon as you can get. And we've added some panels because we, 2 years ago, bought a battery powered electric vehicle. And I've discovered, I've kept track. I'm a little geeky on this. I keep track of these kind of things. That 2/3 of the miles I've driven in that car have been charged at this house, which means they are either directly from my panels or imported from what I put in, and I've exported more than that, so I can really say that I've done it all. And it was difficult at that time. I mean, a lot of the things were unknown, and we had a really good engineer, and it was engineered to come out just about even. And we actually achieved that. It took about a year, maybe almost a year and a half, before the ground source heat pump worked properly, and you know, a few other glitches. But we finally got it all working.
Let me make a note again for the uninitiated. A ground source heat pump, the Earth has a very constant temperature of about 60 degrees Fahrenheit. Mm-hmm. Now, it doesn't sound like a whole lot of warmth, but if you engineer it correctly, you can actually extract that warmth and concentrate it. And so you can heat your house from the Earth by passing cool liquid through tubes in the Earth that take on that heat, that absorb that heat. And you can air condition your home with the same loop.
That's right.
Yeah.
Yeah. And basically what it does, a heat pump does, is it just raises that temperature from, let's say, 60 degrees up to about 85 is all we need to heat the house. And by the end of the winter, actually the Earth is colder, because we've taken heat out of it and not enough heat has flowed in. Mm-hmm. Then all spring and summer and fall, it gets reheated again. So it's completely solar. Everything is solar. We have passive solar on the south side, all of those things, and they all work.
And you don't have to be in the countryside. I have relatives who live in Brooklyn, and the husband is an architect, and the wife is actually my cousin. And he architected a system that he had implemented where under their brownstone in Brooklyn, they have pipes going into the ground doing it.
Right. So there are a number of ways you can do this. So, you know, the other thing is, well, wasn't it expensive? Yes, it was more expensive, and I actually paid some extra to get the engineering done. But now that we have the engineering done, this is being done routinely now. Actually, the daughter of George Woodwell is rehabbing a house in the Boston area And my wife, Margot, who was very involved in the design and construction of this house and has done a lot of consulting to various people, made all kinds of suggestions. And this little house, it was probably built in the 1920s or something like that, is being completely redone and will be net zero because we know how to do it.
Wonderful.
And so you have to ask.
You helped lead the way.
Yeah, that's right. That's right. As my architect said, you know, you could have given all that money to an environmental organization. Instead, you did something much more important. And so I'm pleased to do that.
And before we go on, I want to mention a very, very important P1 solution that you inadvertently brought up, because in this discussion so far, I know people listening to it are going to be reacting, saying, well, I'm not ready to spend the extra money. I'm going to take the conventional electricity and pay less. Folks, P1, a P0 solution, something you need to do is change the value system by which you make your choices. Because if you're always going to choose the cheapest solution, then we will go over the hill. Then we will be falling, because the problem is we value money too highly and we don't value life highly enough. You've got to change your value system so you're willing to pay a little more for doing the right thing to save a whole lot of people.
And of course, it's the upfront cost that's sometimes a barrier for people. But what we discovered is that, I mean, I could have put the money that I put into solar panels into my retirement fund. What we discovered is that not our cost, but our investment in solar panels, I could have put that money into my retirement system. Instead, I put it into solar panels. Those solar panels, the return on that investment did better than my retirement. In fact, better than the entire stock market for over 10 years. By 10 years, I had made more money by saving it with no taxes to pay on those savings than if I had put it into some investment somewhere. So it's important to know that there's short-term costs, but there are long-term benefits. And if you're willing to wait, you know, people say, what's the payback time? Well, the payback time was probably somewhere around 8 or 9 years.
Who cares? Come on. When I say who cares, when I put the solar system on my house, there were very generous state tax credits, but the federal tax credit, excuse my vernacular, sucked. There was a cap for residential at $2,000. So I basically wasted many thousands of dollars of tax credit had I waited. But in that time that I waited, it paid itself back.